Alright guys, this is unit number 8, lesson 1. This is our first lesson in our quadratic functions unit. So this is one of my favorite things to do in algebra, so hopefully you guys will enjoy it too. And you're going to see that pretty much everything we've done so far, or a lot of things we've done, is going to lead into this unit. So we've talked about linear and exponential functions, and now we're getting into quadratic functions. So before we start, I want you to review. Do you remember what the equation for linear functions are? Could you write that down somewhere, maybe over here? And do you remember what the exponential equations are for exponential functions? Maybe write it over somewhere where you have room. So hit pause and see if you can remember those. Alright, so do you remember that linear functions are always in the form of y equals mx plus b? You get some type of equation like this. Y equals 3x minus 2. And remember, we could graph this because this would be the y-intercept, and this is your slope, your rise over run. So basically the m and the b are going to be numbers, and the x is your input, the y is your output. Exponential functions look something like this. Again, where the a and the b are some numbers, and x and y are input-outputs. So maybe something like where a, and then you had the number 3, and then it doubled each time. We did something like that. So now we're going to learn about quadratic functions. Alright, and the thing about linear functions and exponentials, they always increased or decreased when we graphed them. So you might have a linear one that does this, you might have an exponential one that did that, or maybe an exponential one like that. Well, quadratics are going to act a little different, so we'll get into that now. And quadratics also deal with some type of polynomial. So polynomials will be a function, type of function for quadratics. So here is the formula for quadratics. This is quadratic formula here, where it's in y equals ax squared plus bx plus c, where the a, b, and c are going to be some type of number, and hopefully you recognize this as a trinomial. And then the a cannot be 0. So this cannot be 0, b and c can. So that leads to our first question. It says, why is it important for the leading coefficient to be non-zero? So can you explain why this can't be 0? So see if you could write something right here for part A. Alright, well, let's see what you did. Something, or if A was 0, this thing right here, it would look something like this. And if I did that, I'd have to do 0 times x squared, and you know 0 would go away, and then we would end up with something just like this. And this is actually a linear equation. This is like y equals your m times x plus b. So we have to have this x squared term to be quadratic, and if we made it 0, then it would turn into a linear. So that's kind of what we have something written here. And you must have an x squared term to be quadratic. So hit pause and fill that in if you need to. Okay, question B says circle the choices below that are quadratic functions. So just do this really quick. Circle the ones that you think are quadratic according to this formula here. Alright, did you circle this one and this one? Those are both quadratics. You can see in this term the b would be 0. I don't know why that just happened, but that's alright. You know what I'm trying to do. And actually same with that, the b is 0. This one here is not quadratic because you can't have the third term. The highest thing you can have is a degree of 2. And this one, even though we have the x squared, we can't have this. This is actually x to the 1/2 power. So we need to make sure our, remember polynomials have whole number exponents. So this is not a polynomial, so it's not a quadratic. Alright, let's keep going here. So these were the ones I reviewed. So now we have our quadratic equation. So linear equation, exponential equation, quadratic equation. Alright, let's answer some more questions. Part C says for you to write this in standard form, which is this guy right here. And then I want to change this. Instead of saying just write the leading coefficient, I want you to tell me what each coefficient of this quadratic function is. So write it in standard form and tell me what each A, B, and C are. So do that now, please. Alright, so when you did that, you would get something like this. So the x squared comes first, then the x and the no x, and make sure all the signs stay the same. Now it's really important for you to know the first term with the ax, or with the x squared is going to be your a. the one with the x, the second term is your b, and the third term with the one with no x is always going to be your c. Very important for you to identify the a, b, and c terms of a quadratic function. Okay, part D, pretty easy for you. You're just going to find f of -2. So you're going to input -2 into this function, see what you get out, and they want you to write your answer as a point to see what point would lie on the graph if you were to graph this. So do that now, please. Hit pause. All right, when you did the work, you just inserted the -2, the input value, put it in like that. You should always just show us what it looks like first. Don't do the work yet. Then you could do the work, and you get 15. And remember, your input value is your x, and your output y, so then you could write it as a point like that. All right, move on. Now we get into graphing some quadratics. This is when it gets kind of fun. So here is a quadratic function. Notice that the b term and c terms must be 0. That's why they're gone. And the a coefficient is actually 1 right here. Now what we want you to do is go ahead and fill in this table. These are your input values, or your domain. So input those into the function, see what you get out, and fill out that table. So do that now, please. Okay, when you did, hopefully you got something like that. And maybe you thought it was a little weird because you noticed this pattern where you have 9 here, 4, 4, 1, 1, and this 0 is all alone here. Well, this pattern that you see will happen in every quadratic function. The reason why is when you have x squared, if you input a negative, it's going to get you the same thing as inputting a positive. Because -3 times -3 is +9, and 3 times 3 is also +9. This is still a function because each input goes to one output. It just doesn't matter that we have 2 different inputs going to the same output. That is not a problem. So now what we want you to do is go ahead and graph this. And what I want you to do is just graph these points. Don't connect them with lines, and I'll show you why. So just graph the points. Do that now, please. When you graph the points, hopefully you got something like this. Here's the different points. And this thing is called a parabola. It comes up in the notes, so I'll show you that. So it needs to be a curve. So when you do it, you're not going to have sharp points. We're going to make sure it curves, and then you're going to come back up like this. So this is a parabola. This is what the graphs look of quadratics. It could be all over the place. It's not going to be there. You might have one that's over here. You might have one that's upside down. Okay, so, but they're always going to be in this kind of curvy form. Whoops, let me get rid of that stuff. I would say it's like kind of like a U. Okay. So now do you remember how to figure out what the range of this function is? What were the range values? So see if you can remember how to write that. We did that early on this year. Well, remember that the range is the y values. And as you can see that there's no values down here, so the minimum y value is 0. And then as you go, it keeps going up. So it goes on to infinity with those arrows. So you would write it somewhere here. Sorry, I think it's just like that. There we go. So the range is the y values or the outputs, and here's your different ones here. So you could write it either in this form, y could be greater than or equal to 0, or remember we can include 0, inclusive, we exclude infinity because you can never include it. All right, let's keep going with this. Okay, here's another one, and there's what I mean by parabola. So that graph, that's how you pronounce it. It's called a parabola. All right, so here we have a more complicated quadratic than before. Now this is going to change things around. It's not going to be just as easy as the last one. So you could actually put this in your calculator in the y equals form and write x squared minus 2x minus 8. Put that in your calculator and generate a table. So go ahead and do that now, and then you're going to put your table down here. All right, I already got it there. And then go ahead and graph the points. Now you might say, well, which point should I use? Well, use all the points that would fit on the graph. So you figure out which points would work for this graph and go ahead and graph that now. So hit pause, do the table and the graph. All right, when you did that, you got something like this here. And the reason we picked these points because these are the ones that fit on this grid here. If you go too far in that, they won't fit. And when you graph that, you get something like this. For now, ignore this line. Now notice that things are a little weird here. We have the 7 and the 7 and the 0 and the 0 and the 5 and the 5. Typically what we like to do is put that middle point right there. And notice that, well, the 4 get you a 0, but this is not like -4. That's because we're doing a lot of extra things. We're not just squaring a number, then we're subtracting and subtracting. So these y values that repeat won't always have the same x input, so don't think that. However, just the y values are the same, and you can see that here. Like these have the same y values, but not the same x values. Same y values, but not the same x values, okay? All right, so there is your parabola, nice and curved. Hopefully you made it. Make sure you put arrows at the top. Now, could you state the range of this guy, of this function here? So try that. Okay, that would look something like this. The minimum value is -9, and it goes up into infinity, so y can be greater than -9, or write it this way. Next, could you write the domain when it's increasing? So when is the domain increasing? Could you do that now, please? All right. When you do that, you would get something like here, because remember that it is an increasing. Right after this point, now it's starting to increase. And domain is x value, so at this point, what is our x value? 1. Anything past 1 makes it go up. So that's when we're reading this. Like if I looked at this value, it's going to be way up there somewhere. Okay. So here is your increasing domain. Okay, next we have this term called the turning point. Very important term to get down. This is also known as the vertex. Okay? And it's not always referred to the minimum, because you could have a parabola like this, and therefore it would be the maximum point. But the turning point is just this one down here, where the graph changes. So here it's going down, 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 it hits this point, now it's going up. So this is the vertex or turning point. So we can write the coordinates of that here. Another very important term is called the axis of symmetry. That is a line that cuts the parabola in half. Symmetry means when two things are equal on each side. So if I draw this line right here, it kind of splits the parabola right in half, and both these sides are equal now. So that's called the axis of symmetry. And we could write the equation of the line like this, since it's a straight line where x is always equal to 1. All right. And finally, it says, what are the x-intercepts of this function? Simply, where does it hit the x value? These are also known as the zeros. And then why does this make sense? Well, this is something we're going to learn. Very important. But here is where the graph hits the x-axis. So these are called the x-intercepts. And there's the points. When x is -2 and x is 4, that's actually when y equals 0, so that's why we call it the zeros. We input the x and it gets out zeros. See right here? And that's why we call it that. So the zeros are the functions, is when the graph is the y is 0. So what inputs get us y of 0? All right, so write those in if you need to. And we have to kind of go do this last part fast, but I think you'll be pretty good at this. So on this one, simply tell us what are the coordinates of the turning point for this, and what is the range of this quadratic function. So can you find the turning point and the range for this function? So hit pause, and why don't you do both of those now. Okay, so hopefully you look for that pattern, and you can see it right here. Because we have 12 with the 12, 9 with the 9, and sometimes in your table, this is not always going to be right in the middle. Like it could be way down, well, that's not a good one. It could be here, and you might see a pattern, but you're looking for the one that has its own point all by itself. So that is the turning point right there. And we could write that in. And what was the range? Well, remember, those are your outputs or your y values. So you wouldn't say 4 to -2. You look for the smallest one, and this one, actually what you can see is this is the max 13, and now it looks like it's going down. So it looks like 13 is the maximum amount, and everything's going below it. So now you have to do something like this, where y could be equal to or less than 13, and the minimum value for the y is -infinity. The maximum is 13. So there's your range. This would be your domain. That's pretty straight and simple. It goes from -1 to 6. All right, guys, so hopefully that went okay with you, and we'll practice some of this in class tomorrow.